Good afternoon, fellow learners, technical science learners. Welcome to this important presentation where we are taking you through to the examination, and then this is the last effort that we are making just to make sure that you are quite prepared for the examination. My name is Mr. M.I. Sefo. I am the subject advisor for physical science and technical science from Lejwe-Leputswa district. Today I will be taking you through the examination tips for technical science grade 12. Though it is presented, this presentation was supposed to be done by Mr. Sipiwe Sibanyoni, who is the chief marker of technical science paper 2 in the province, but due to some matters he could not make it today. Therefore, copyright reserved. I will be taking you through the presentation that was made by Mr. Sibanyoni, while we'll be looking especially on the examination tips for technical science grade 12 paper 2. We'll thoroughly look at what the paper entails. We will also look at what are the common mistakes that are made by our learners due to the marking experiences in previous years. That is what the presentation is all about. And there will be some marking guidelines, tips for you so that you become aware what is it that you must expect, or what are the mistakes that you must avoid in the examination so that you cannot lose many marks. Let's go through the presentation. This is the presentation outline. We'll be looking at the structure of the question paper, how are the cognitive levels, and then the mark allocations per topic, and then common errors and mistakes per topic, and then we'll also be importantly looking at the marking principles. This is the most important thing, that we must basically look at the common errors and mistakes per topic as well as the marking principles. This is the structure of the paper. In our paper, you will get the multiple choice questions, and that multiple choice questions will encompass all the topics for paper 2. That will be 10 questions, 2 marks per question, and then that will take us to 20 marks. And we are appealing that we are not expecting that we will ever get any multiple choice questions without any answer, because what you are given in a multiple choice question, you are given 10 questions. Per question you have got 4 possibilities. That is option A, option B, option C, as well as option D. Yours is to choose the correct answer by writing either 1.1A or 1.1B or 1.1C or 1.1D. And there is a technique of answering a multiple choice question that we have been emphasizing throughout the year, that in any multiple choice question, 4 possibilities that are given, 2 of the possibilities are totally incorrect possibility. You must start first by eliminating the totally incorrect possibilities, such that you will be left with 2 possibilities that are closer towards the answer. And then once you have got 2 possibilities that are closer towards the answer, the probability of guessing correct is now higher than when you have got 4 possibilities. Read the STEM, that is the statement problem, thoroughly and understand what does the problem statement say about the question. Link your statement problem with any principle that can help you to answer the question, and then so that you can be able to choose the correct answer. I also emphasize, we are not expecting that you will have got any blank space on a multiple choice question. If at any point you are not sure what is it that you will be answering, therefore you better choose any answer, either A, B, C, or D. Maybe the chosen one will be the correct one, but we are discouraging that we got a question in a multiple choice question that is goes unanswered or without any possibilities. I hope that one is clear. Then the question paper will also consist of long structured questions. That will be either question 2 up to question 10 depending on the length of the paper. And then on the question paper you'll also find the data sheet that has got your physical constant. And you'll have got table 2 that contains the formula per topic. It means if you are talking of the light, the formulas that are basically for that topic that is light will be structured or put together. If we are talking of maybe another topic, then its formulas will be packed together. And we have got the table of standard reduction for electrochemistry, that is table 4A or table 4B. And my advice will be, if your teacher have introduced you to topic 4A, don't ever bother looking at table 4B. If your teacher have taught you to use table 4B, don't bother to use table 4A. And my advice will be, a minute you get that question paper, you are allowed to take out the table for physical constant and table for the formulae for the topic, and either table 4A or 4B, depending on which table were you using in class. Take them out from the question paper and then put them aside, so that every time you have to do a calculations on light, refer to the formulas on light to see what are the formulas that you can use for light, and then pick up the formula from the data sheet and then write down the formula as it is on the question paper, and then try to substitute on that question paper, and then as well as the table of standard reduction potentials, either table 4A or 4 or 4B. This is what you will get from the question paper. And then these are just the cognitive levels. We have got 4 cognitive levels, that is the remembering, understanding, analysis, as well as the creation, synthesis. 40% of that paper will consist of the remembering. And remembering include the recall of definitions, the recall of principles, etc. My dear learners, I want to emphasize this. If 40% of that makes up of the remembering, therefore it means you go out there and then you make it a point that you master all your definitions, you master all your definitions, you master all your principles. Therefore it means 40% of that paper. Remember what you need to pass, you need only 35%. It means with recall, that is the remembering of all of this, then you can even pass that. 30% will come from an understanding, that is comprehension, where you have to make a decision based on an in-depth reflection, criticism, and assessment. And then where you'll be working at an extended abstract level. And then that understanding, that is paper 2, that is level 2. More often you'll find that it consists of what? It consists of the calculations. And whenever you calculate, remember, we always says that, remember the concept of an F sort, that you give us the formula, you put a substitution into that formula, and you write the unit with the final answer with the correct SI unit, and then you give us the direction if you are talking of velocities or etc., of which in paper 2 you won't be dealing with that. It means this level 2 questions, that is where you'll get your calculations, like in your electrochemistry. That is where you'll get your calculations, like in light. That is where you can collect the marks. And then analysis, where you will appreciate the significance of the past in relation to the whole. You analyze the situation so that you can be able to give the significance of that. And then that will be 20%, and therefore synthesis, that will be your level 4, that is 10%. It means The bulk of the marks is on level 1 and level 2. That is where we must emphasize. That is why I'm emphasizing that. Make it a point that you go out there, you know your definitions by heart, so that you can collect at least this 40%. And you know your understanding that is not at a higher cognitive level, but higher cognitive level than level 1, then you can be able to collect the marks, and therefore you'll be able to pass. Remember, passing is all about collection of what? The collection of the marks. And therefore, these are the topics that we will be dealing with in paper 2. You'll have got the questions from organic chemistry. And then that organic chemistry is divided into 3 sub-questions, subtopics. Nomenclature of organic molecules, physical properties, as well as the organic reactions. Plus or minus 54 marks of that organic chemistry. Remember that plus or minus 54 marks also includes some questions that you'll get in the what? In the multiple choice questions. It means bulk of the marks in that paper will go towards the organic chemistry. And therefore, you'll also be examining on the light, that is reflection, refraction. That will also include lenses as well as the dispersion. Plus or minus 41 marks. And therefore, electromagnetic radiation, that is plus or minus 12 marks. And also your electrochemistry, that is 43 what? That is 43 marks. And then the whole total paper of that will amount towards 100 and what? Will amount towards 150. That will be the total paper. That will be 150. And let us look at that. We are now going to look at the paper, the topic per topic. Try to find out what is it that you must know. Try to find out what are the misconceptions that you are having. What are the mistakes that the previous learners have been committing, so that you can be able to correct those mistakes. What to know from organic chemistry? This is derived from your examination guideline. You must be able to define organic molecules as molecules that contains the carbon atoms. It means 2 marks. If a question says define what are the organic molecules, that will be molecules containing carbon atoms. And that is 2 marks. It is a recall type of question. And you are expected to write down the molecular and structural formulae of organic compounds up to 6 carbon what? Up to 6 carbon, that contains up to 6 carbons. For the alkanes, we are not concerned with the ring structure. For the alkenes, the alkynes, the alkyl halides, which are the haloalkanes, distinguish between primary, secondary, and tertiary haloalkanes. For the aldehydes, for the ketones, alcohols, carboxylic acid, as well as esters. Remember, what is the difference between a molecular and a structural formula? In a molecular formula, we only indicate the type of atoms that makes up the molecule, how many atoms in that molecule. Like for an example, if we are referring towards what? If we are referring to a molecule like what? A molecule like your butane, it means the molecular formula, it is C4H what? It is C4H10. That will be the molecular formula of that compound. But what will be the structural formula? This is what we refer to as the molecular what? As the molecular formula. And as much as you are writing this molecular formula, remember you are also expected to be able to define what a molecular formula is from the data sheet. Therefore, I will be saying that every time you read with an understanding, and then always take note of the concept that you must remember. That will be the molecular formula of that compound, which is known as a what? Which is known as the butane. But what will be the structural formula of that compound? The structural formula will be where we indicate the carbons that makes up that molecule. And then where we have got 4 carbon atoms, that is why the molecular formula becomes C4. And therefore we have got what? We have got there the hydrogen what? We have got there the hydrogen atoms there. And then remember what happens is that when you draw the structural formula, then you should indicate the hydrogen what you should indicate the hydrogen atoms, and therefore that is the difference between the molecular formula as well as the structural the structural formula. And therefore remember, for each homologous series you must be able to write that up to the homologous series that contains 4 carbon atoms. You must be able to write that up until the molecular formula that contains up to the one that contains 8 carbon that contains 8 carbon carbon atoms. And therefore that is what I wanted to emphasize. What is the difference between a molecular formula as well as the structural formula. Little bit challenged with the technology, but I will get it right. I want to go back to my presentation. I will get it right by now. The slide. Yeah, right. Coming back, what I was defining was, I was just making the difference that you must be able to write the molecular formula and the structural formula of organic compound up to 6 carbon atoms. And then these are the homologous series. It means for alkanes, up to an alkane that contains 6 carbon atoms, an alkene that contains 6 carbon atoms, alkyne, alkyl halides, aldehyde, ketones, alcohols, carboxylic acid, as well as the esters. And then what you also need to know is that you must be able to distinguish between homologous series, between different types of homologous series. These are the different types of homologous series: alkanes, alkenes, alkynes, alkyl halides, etc. And you must be able to differentiate between what we call saturated and unsaturated hydrocarbons. And you must be able to identify compounds up to 6 carbon atoms that are saturated, unsaturated, and are structural, are isomers. We had a very challenge with the learners last year who could not differentiate between isomerism. Structural are isomers, either positional, structural, or whatever. And then know the general formula of different homologous series. My dear learners, when we say we must know the general formula of different homologous series, you might get 2 questions. A question might be saying that write down the name of the general, write down the general formula of the general formula of the alkanes. And then what is that general formula? That is CnH2n plus 2. And therefore, for every homologous series, you must know that general formula. And then hydrocarbons, you must be able to define the weight hydrocarbon. And once you reach the weight hydrocarbons, it means self-explanatory. Hydro for the hydrogens, carbons for the carbons. It means these are the organic compounds, the weight organic there. Organic compounds that consist of hydrogen and carbon atoms only. That is why they are referred to as the hydrocarbons. And you must be able to differentiate between a saturated hydrocarbon and as well as an unsaturated hydrocarbon. Remember, it is saturated because it contains only single covalence bonds between the carbon atoms. And we had a problem of learners which says that it is saturated because it contains only single covalent bonds. It can be saturated. It can contain single covalent bonds, but it can be single covalent bonds between a carbon and a hydrogen atom. But now we are looking at the bonds between the bonds between the carbon atoms. It means we are saying that it must contain only single bonds between the carbon atoms. Therefore, if you are only saying single covalent bonds, therefore you are going to forfeit marks because it must be single covalent bonds between the carbon atoms. Remember, unsaturated compounds also contain single bonds, but it is single bonds between the what? Between the carbon and the hydrogen atoms, whereas a saturated one will contain single bonds between the carbon atoms. That is why it's very important that you must be able to tell us where are those single bonds. Unsaturated double bonds or triple bonds between the carbon atoms. And therefore the definitions are very important. There are a lot of definitions in in organic chemistry that we expect that you must know by what? You must know by heart. Definition of a functional group. Remember, what makes a difference between homologous series is that different homologous series have got different what? Have got different general formula, and they have got different functional groups. And we define that as an atom or a group of atoms that determines the chemistry of a molecule, or an atoms or a group of atoms that determines the physical and chemical properties of a group of atoms, of compounds. And we define homologous series as a series of organic compounds that can be described by the same general formula, and where each member differs from the next by a CH group. I'm not saying this is what is going to happen. In previous question papers, we might find out that some of the definitions are being part marked. If a definition is for 2 marks, you might find that the examiner have part marked that definitions. I'm making an example of a homologous series where I've seen that the examiner have part marked that definition of saying a series of organic compounds that can be described by the same general formula. Then an examiner gave 1 mark up to that extent. And then where each member differs from the next by a CH group, and then he give another mark for that. But that is not what I am encouraging. But what I am saying is that make it a point that you know your definitions by heart. Remember, 1 mark in the examination is very, very much important. If it is a definitions, make a point that you collect as full marks, that is 2 marks for every definitions. And then what you know in organic chemistry, I've already highlighted how do we write the structural formula for a given isomers and name them. A structural formula for a compound, it shows atoms are attached to which within the molecules, and we represent the atoms by their chemical symbol. This is a carbon atom, and then this carbon atom is attached towards another carbon atoms, but there are 3 other hydrogen atoms that are there, and therefore the lines are used to represent all the bonds that hold the atoms together. Remember this, every carbon atom can make a maximum of 4 covalent bonds. Once you have drawn a structural formula, just make it double check that your carbon atoms has formed more than a maximum of 4 bonds. It must not form less than 4 or more than 4. Let's make an example of what we are having in here. You can see these carbon atoms. Most of the learners, what they do, they will put a hydrogen atoms here, a hydrogen atom, another hydrogen atom, and then once you put a hydrogen atom here, it means the whole structure becomes incorrect, because now this carbon atom will be forming 1, 2, 3, 4. Then you put another one, then that is 5 carbon atom, and then also the functional group becomes incorrect. Always make it a point that your one carbon atoms has formed 4 bonds. 1, 2, 3, 4 for this carbon atoms. 1, 2, 3, 4 for this carbon atom. 1, 2, 3, 4 bonds for this carbon atoms. 1, 2, 3, 4 for bonds for that carbon atoms. That is one important aspect that you must also take into consideration. The structural isomers, I alluded earlier that we had learners that were losing marks last year because they cannot define what a structural, they don't know the concept of isomerism. Remember, what are the structural isomers? They are the organic molecules with the same molecular formula, C4H10. but they have got different structural formulae. The molecular formula is the same, C4H10, but when you draw the structural formula, then they differ. But on that structural formula, my dearest learners, you must be aware that we have 3 types of structural isomerism. I'm talking isomerism now. We have got structural isomers, but we have got 3 types of structural isomers. That is 1, chain isomers. Chain means the branch chain, the side chain. You can take it from that. The side chain. The side chain. Positional isomers will mean the position of the functional group. Where is the position of that functional group? On which carbon atoms do you get your functional group? Chain isomers will mean on which carbon atoms are we having the chain. And then functional isomers will just be meaning, you can take this functional isomerism from the word functional group. It means once you talk of functional isomers, you are meaning they will be the same molecular formula, but from different from different homologous series. That is, the functional group is not the same. It means what is more common in chain isomers, positional isomers, and functional isomers. The word in definition is that they are organic molecules with the same molecular formula. That one you get it from each and every one, same molecular formula. But if they are chain isomers, but different types of the chain, positional isomers, different position of the functional group. Functional isomers, different functional groups. And therefore, this is a difference, an example of the what? Of the chain isomers. When you look at this is a butane. The molecular formula is C4H10. 4 carbon atoms, 10 hydrogen atoms. That is the molecular formula. You look at this one, 4 carbon atoms, 10 hydrogen atoms. It means the molecular formula is C4H10. But when you look at this is a straight chain compound. And then this one, it is being branched. It just got a chain, a side chain. It means this is 1, 2, 3. The chain contains 3 carbon atoms, but it has got a side chain. That is why it is referred to as a chain what? As chain isomers. Same molecular formula, but different types of what? Of chain. And therefore, this is butane, and therefore that will be a 2-methyl what? That will be a 2-methyl propane, or just a methyl propane. And positional isomers. Remember, previously we said same molecular formula, but now different chain, types of chain. This one, no chain. This one has got a branch. And therefore, when we go towards the positional isomers, it means here, same molecular formula. But now, because it is positional isomers, different position of the side chain, or different position of the substituents or the functional group. You look in here, same molecular formula, your chain is 3 carbon atoms. But what is your functional group? This now, your functional group is the chlorine atom, your chlorine atom. In this compound, your chlorine atom is attached towards one carbon, the first carbon atom. In this compound, your chlorine atom is now attached to the second carbon atoms. It means the molecular formula is the same, but now different side of the what, or different position of the functional group. That is why it now becomes 1 chloropropane. It is now becomes 2 chloropropane. A propane will mean the longest chain contains 3 carbon atoms. Propane, longest chain contains 3 carbon atoms. But this 1 chloro, we now make a point, where do you find that chlorine atom? Where do you find that functional group that makes these molecules a haloalkane? Your chlorine is on carbon atom number 1. Your chlorine is on carbon atom number 2. 1, 2, 3. 1, 2, 3. And if it is not like that, look at this compound. This now comes from another homologous series, which is now your alkenes because of the double bond. Look at the position of the double bond. The position of the double bond is just after carbon atom number 1. But the position of the double bond in this molecule is just after carbon atom number 2. Hence, this molecule will not be a butene. It won't be a butene, because once you say a butene, but will mean 4 carbon atoms. But because it is an in, we want to know where is your functional group, where is your double bond. Therefore, it means but 1 in will mean your double bond is just after the first carbon atom. Your but 2 in will mean your functional group, which is a double bond because of that in, is just after the second carbon atom. That is your isomerism. That is your positional isomers. And then what are the functional isomers? In functional isomerism, same molecular formula. You'll remember that I've said that same molecular formula from chain isomers, positional isomers, same molecular formula. What differs is, in this regard, is now different functional groups. It means I've got 2 molecules that comes from that have got different functional groups. Different functional groups is that 2 molecules have got comes from 2 different homologous series. And I want to make it as simple as possible. We have got a pair of 2 functional groups that are functional isomers. This is a methyl methanoid. This is an ester. And then this is an ethanoic acid that comes from the carboxylic acid. 1, 2 carbon atoms, 1, 2 carbon atoms. 1, 2, 3, 4 hydrogen atoms, 1, 2, 3, 4 hydrogen atoms. 1, 2 oxygen atoms, 1, 2 oxygen atoms. But when you check is that the functional group is not the same. The functional group here, it is here. COOH, that is the carboxylic group. The functional group here, it is here. That is the COCO. I've been told you that once you can read the word cocoa, then you know that you have got what? You have got an ester. These 2 molecules come from different functional groups. It means a first pair that I'm referring to is that esters can be positional functional isomers of what? Of carboxylic acid. And then the other one that can be functional isomers are your aldehyde as well as the what? As well as your ketones. Remember, your aldehyde and your ketones, they have got the same functional group. What is the functional group? That is them. They contains this functional group. C double bond what? C double bond O. C double bond OO. That is an alkyl group. Therefore, they can be the functional isomers of one another. Right. This is also very important. We must be able to write down the IUPAC name when given the structural formulas of the alkanes, alkenes, alkynes, alkyl halides, haloalkanes, aldehyde, ketones, alcohol, carboxylic acids, and esters. But we are going to restrict that towards 1 functional group per compound, except for haloalkanes. It means for the haloalkanes, remember, a molecule can be a molecule that contains 1 functional group, that is the chlorine, like this one. But now for haloalkanes, it means the statement is saying I can have got a chlorine and a bromine in 1 molecule. That is what is meant by 2 functional group for the haloalkanes. We cannot have got chlorine, bromine, and fluorine in one compound. That is chlorine and bromine, or chlorine and fluorine, or fluorine and etc. That is what is meant by this statement. Therefore, it means once you give that, you must be able to write the IUPAC name. And then once we give you, it means we give you the structural formula, you must be able to write the IUPAC name when given the structural formula. And when given the structural formula, you must be able to give us the IUPAC name of all the homologous series. And then identify the alkyl substituents, your methyl and your ethyl, in a chain to a maximum of 2 alkyl substituents on the parent chain. Where do you have got a methyl? Where do you have got an ethyl? I just want to make one more example of what we mean by a methyl and an ethyl. It means we have got the problem of saying most of the learners struggle in terms of identifying homologous series. I will make just one example of that. I have got a compound in here, and that compound contains this, and let's add 1 2 3 4 5 then 6, because we are dealing up to 6, and we put, let's remove this one, and then let's put a hydrogen atom in here. How do we name this organic compound? I normally say to learners that I am not looking for the longest carbon chain, but I search for the longest carbon chain. There is a difference to me. There is a difference between looking and searching. Because when I look, I just look and then I make a decision. But when I search, I go in there. I now start 1 2 3 4 5 6. That is the possible chain. 1 2 3 4 5 6. That is the possible chain. 1 2 3. That is the possible chain. It means I've got 3 possible chains. Starting from there, going straight is 6. Going there is 6. Going this way is also 6. Going that way is also 6. Therefore, it means now, because it contains 6, the longest chain contains 6. Therefore, its name will now be a hexane. But now, because it is branched, therefore, I must now decide which chain am I looking at now. That can I can say that this is now what? This is now my chain. But to look at the chain, it means I must decide which chain. 6, the one that makes hexane, it is 1 2 3 4 5 6, or 1 2 3 4 5 6. And therefore, it means if I take it a straight chain, therefore it means I have got what? I've got a substituent here. This is now my branch. And then my branch, it is now a methyl. Where does the methyl comes from? My branch, it is now let me remember, a methyl ethyl. Yeah, this is my a methyl. Therefore, it means I must now name this in my chain. Remember that methyl comes from a methane with 1 carbon atom, that is a CH1, that is a CH4. But we remove 1 carbon atoms, we are left with what? With a CH1. We are left with a CH3, hence it now becomes a methyl. And therefore it means this will be my carbon atom number 1, carbon atom number 2, number 3, number 4, number 5, and then that will be my carbon atom number 6. And therefore it means, where do I get the substituted chain? It is now on carbon atom number 2. That is why the name now becomes a 2-methyl. Sorry for that. That now it becomes a 2 what? A 2-methyl hexane. A 2-methyl what? A 2-methyl hexane. That is what we mean by the branches. It might happen that you might find more than 2 branches where you have got an ethyl, a methyl as well as an ethyl. And then in that regard, it means you have to name both methyl and ethyl in your what? In your name. That is what I meant by saying the alkyl substituent, an ethyl as well as a methyl and an ethyl in a chain, to a maximum of 2 alkyl substituents on the parent chain. And learners, when naming haloalkanes, very important, the halogen atoms do not get the preference over the alkyl substituents. What do we mean by saying that it does not get a preference? Numbering should start from the end nearest to the first substituent, either an alkyl group or a halogen. In haloalkanes where your bromine and chlorine have the same number, let's start first by explaining what we mean by saying that. In haloalkanes, your halogen atoms do not get the preference. It means when I have a molecule, and in my molecule I have got this. In my molecule I have, let's say, a molecule C, 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 C. And here I've got a CH, and I have got what? Let's say I've got a Cl. Then this qualifies this molecule of mine to be a what? This molecule of mine to be a haloalkane. And remember, every time you draw these molecules, you must indicate the hydrogen atoms, because we found the situation where these are drawn but the hydrogen atoms are missing. And therefore it means, what we are saying is that some learners will think that because this is now the functional group, which is a Cl, therefore it means I must number my molecules, my carbon atoms from this side going that side, so that the functional group get the preference. But that is not the case in the what? In the haloalkanes. But what is the case in the haloalkanes is that either this or that will get a preference. What we are looking at numbering your carbon atoms from the side where your number, we are looking for the lowest possible number. Remember, this is, if I say carbon atom number 1, number 2, number 3, number 4, and number 5. We are looking for the lowest possible number. It means my side chain will be a what? Will be a 3 chloro, and then 2 methyl. 2 methyl. It means, what are my numbers? My numbers is 3 and 2. That will give me what? That will give me 5. But in case you decide that you are going to number this compound from this side to go in that side, it means that will be your carbon atom number 1, carbon atom number 2, carbon atom number 3, carbon atom number 4, and then carbon atom number 5. And then where you have got your substituents now in this regard is on carbon atom number 3 and carbon atom number what? And carbon atom number 4. It means that will be a 3 and a 4. A 3 and a 4 will give you 7. But here I'm having what? I'm having a 3 and a what? A 3 and a 2. And then that will give me what? That will give me 5. We are looking for the lowest possible number. The lowest possible number in that regard, that will be 5. Hence we are saying your alkyl group does not get the what? Does not get the preference. But what get the preference is that we are looking for the lowest possible what? We are looking for the lowest possible number when we name the haloalkanes. And therefore, that is that. And therefore, in a haloalkanes where a Br and a Cl have the same number, when numbers from different ends of the chain, the Br gets alphabetical preference. Therefore, it means, what is meant by that statement is that in case I have got a scenario whereby my molecules is this type of a molecules, let's make 4 carbon atoms, and then I've got what? I've got a Br, and then I have got what? I have got a C, a Cl, and then in here I've got what? I've got the hydrogen what? I've got the hydrogen atoms. It means if I number these compounds of mine, it means from this side towards that side, that is carbon 1, 2, 3, 4. It means it's carbon atom number 2 and carbon atom number 3. And also when I move from that side to go into this side, it will be carbon atom number 1, number 2, number 3, number 4. It means going either this way or that way, I still have got 2 and a 3. That will give me the lowest number as 5. Going that way, I still have got what? I still have got a 2 and a what? And a 3. That will still give me what? That will still give me 5. But now, what will be the correct numbering now is that now I took the alphabetical order. Therefore, this get what? This get a preference on top of what? On top of the CL, because a B comes before C in the alphabet and in alphabetical order. Therefore, it means now this will go with this numbering of what? Of 1, 1, 2, 3, 4, because now your BR will now get the preference on top of that, and therefore that is what is meant by that. And also, when writing the IUPAC name, substituents appear as prefixes. Write down alphabetically 2-bromo, 2-chloro, ethyl, and a methyl. Remember the concept of alphabet, that when we name this, we cannot say 3. We can't say this is a 3-chloro, but what do we say? Let's make an let's have got a clear picture of what I mean to say by saying that in case I have got a compound, and then that compound, it is this type of a compound, and therefore it has got what? It has got a chlorine atom, and then somewhere it has got what? Somewhere it has got let's say a bromine what? A bromine atoms with the hydrogen atoms. Remember, myself, I'm a teacher. I may not need to add the hydrogen atoms, but you must remember that when now you don't have got a metric certificate, every time, even when you practice, you must add those hydrogen atoms. You must add those hydrogen atoms. I guess in the next presentation, as I move forward, I will not add those hydrogen atoms for the sake of time. But it means when we name this compound, it means we will name that compound as a what? We will name that compound as a 2-bromo, then 3-chloro, butane. 2-bromo, 3-chloro, butane. It means now what is important is that bromine will come before chlorine in the naming. Even if we have got different substituents groups like your methyl, if I'm having a bromine and an ethyl, it means a bromine will be named before an ethyl. If I'm having an ethyl and a methyl, it means an ethyl will come before what? Before a methyl. And that is that, learners. And that is that in terms of what? In terms of the nomenclature of organic compound. We will look at what are the mistakes that learners are committing in nomenclature in a near course in some few minutes to come. But that is one part of the what? Of the organic chemistry that will come across. And one subtopic in organic chemistry, it is on the physical properties. And I will want to say, my dearest learners, in physical properties, most of the questions that you'll find there, they will need you to understand, read, and make a conclusion. And as and when you make that conclusion, please and please, when you answer, don't write a long story. Just write this in a point form. In here, what we are looking at the relationship of the physical properties of the homologous series. But we compare, remember, physical properties of organic molecules. We refer to the boiling point, melting point, vapor pressure, and viscosity. And once I say boiling point, you must ask yourself, what is the definition of a boiling point? Do I know the definition of a boiling point? Because it is a possibility. It is one question that can be answered, that can be asked. Define a boiling point for 2 marks. Can you be able to define a melting point? Then you must be worried that I cannot define a melting point. Then you must go back and then try to define a melting point. Can I be able to define what is a vapor pressure? And in physical properties, what determines at which temperature will a compound boil, melt, and what will be the vapor pressure and the viscosity of that? All that depends on the strength of your intermolecular forces. All that depends on the strength of your intermolecular forces. It means we are comparing two things in here. We are comparing your physical properties to the strength of your intermolecular forces, how strong your intermolecular forces are. Hence we said that compare physical properties of different homologous series. And for every given example from the above functional group, explain the relationship between physical properties and the following: the strength of intermolecular forces, hydrogen bonds, dipole forces, induced dipole forces. It means what is more important is when you look at a homologous series, or when you look at the structure in the question paper, you must be able first to identify the type of homologous series that act between the molecules of that. And once you have identified the type of intermolecular forces that can act within the molecules of that, then compare whether they are the hydrogen bonds, dipole forces, or induced dipole forces, because hydrogen bonds are stronger than the dipole forces, and the dipole forces are stronger than the induced dipole forces. Remember, we normally use the word London forces for the induced dipole forces. And the type of a functional group. You change the functional group, you are changing the type of intermolecular forces, the chain length as well as the branch chain. It means every moment you must be able to identify which factor is affecting the strength of the intermolecular forces. It means we are looking at the factor that affect the strength of the intermolecular forces, so that you can link that factor towards the change in physical properties, right? And you'll also be looking at the reactions of organic compound, oxidation, that is the combustion of the hydrocarbons. Write down an equation for the combustion of hydrocarbon in excess oxygen. My dear learners, if this question arises on Monday, it will cost you 3 marks, and then it is something that you cannot miss. Because whenever a hydrocarbon combustion will mean that will be your hydrocarbon together with what? With oxygen. And then the product of that will be your carbon dioxide and what? Your carbon dioxide and water. It means the product of that will be your carbon dioxide plus what? Will be your carbon dioxide plus water. Very important. It means if this compound is combusted, it means combustion will mean it will react with oxygen O2. And once you have said that, and then there is now, what are the products? The product of combustion in excess hydrogen won't change. In excess oxygen won't change. It will always be carbon dioxide plus what? It will always be carbon dioxide plus water. Whatever hydrocarbon is going to undergo combustion, the product is that it must react with oxygen. The product is carbon dioxide plus water. And then once you have written that, then you already have got 2 marks. One for the reactant and then one for the product. And then once you have balanced that, then you will get another what? You will get another mark for doing what? You will get another mark for balancing. And then that will be the third what? That will be the third mark. It means these are the marks that you cannot afford to lose in a what? In an examination. If that type of a question can arise in the what? Can arise in the examination coming this Monday. And therefore, We are also going to look at the substitution and addition reactions. Identify reactions as substitution or addition. Substitution. When you substitute, it means you take one atom out, then you replace it with another one. Like in any game of soccer or what. When we substitute, we take this player and then we put another fresh player. In addition, it means we are going to add. And then write down structural formula and then equations and reaction conditions for the following addition reactions. Hydrohalogenation, where we add a hydrogen towards the halide. Hydrogen halide. Hydrohalogenation, hydrogen halide to an alkene. Halogenation, reaction of halogens, we add halogen. Hydration, we add water. Hydrogenation, we add hydrogen. It means all these are self-explanatory. Hydrohalogenation, it means we have added a hydrogen halide. Either a hydrogen bromide, a HCl, HBr, HF, etc. That is a hydrogen halide. A halogenation, we add only a halogen, a Br2 or a Cl2 or an F2. A hydration will mean we add water, we add H2O. Hydrogenation would mean we'll add hydrogen. And then homologous series that can undergo this. Addition, only the unsaturated hydrocarbons, that is the alkenes, because that double bond breaks up, more atoms can be added in. And write down structural formulae, equations and reaction conditions for the following substitutionary reactions. It means a substitution reaction, hydrolysis of haloalkanes, hydrolysis, reactions of compound with water, reactions of this to produce haloalkanes, and then halogenation of alkanes. The reactions of halogens with this. These are what we expect you to know. And this is just a schematic representation of what we expect. These are the organic molecules. We are talking of the hydrocarbons. They are saturated or unsaturated. Alkanes, carbon-carbon single bonds. Alkenes, carbon-carbon double bonds. Alkynes, carbon-carbon triple bonds. And this one contains only hydrocarbons. Haloalkanes, we replace one of the carbon atoms either with this, where you see a fluorine, a chlorine, a bromine, as well as an iodine. Then you are on the haloalkanes. And then from a haloalkane, you go to the alcohols. Then you see an OH, that is the hydroxyl, a carboxylic acid. This is the functional group of the carboxylic acid. And then a ketone, this is the functional group, and then an aldehyde. Remember, this and this can be what? It can be functional isomers. And then this one can be functional isomers of the what? Of the esters. And then the types of reaction, substitution, addition, and combustion. But you will never be asked anything on what? On esterification. Esterification is not part of the syllabus. Nothing will be asked on that. And then this is just a schematic representation of the what? Of the organic chemistry. These are the hydrocarbons: alkanes, alkenes, alkynes. General formulas, functional group. Remember, when you draw the structural formula of the functional group, you don't indicate, you just indicate the bonds with no what? With no hydrogen atoms. And then these are the examples of that. And then these are the examples of that. And then what are the intermolecular forces? All of them contains the London forces. All this homologous series contains London forces. But hydrocarbons contains only London forces. But you go to haloalkanes, esters, aldehyde, ketones, carboxylic acids, and alcohol. All of that, in addition to London forces, they will contain the dipole forces. But these two, in addition to London forces, dipole, they will contain the hydrogen bonding, hydrogen bonds. But the hydrogen bonds in the carboxylic acids, remember, are stronger than the hydrogen bonds in the alcohols because of that two ends of the what? Of that. And therefore, this is what we have been referring to. Boiling point, melting point, viscosity, pressure. Look at these molecules. CH3, CH2, CH3, CH3, CH2, CH3, all these molecules, they come from the same homologous series. That is the alkanes. Therefore, it means what is common between them is that the type of intermolecular force is the same. All of them contains the London forces. Same intermolecular forces, but the strength of intermolecular force is not the same. What now influences the strength of the intermolecular forces? That is the chain length. This is longer chain, this is shorter chain, this is the shortest of the chain. It has got the shortest chain as compared to the three. It means as you increase the chain length, or you increase the surface area, or you increase, basically you are increasing the strength of the intermolecular forces. It means, one, if I have to explain this in a point form, one, I will just be saying all compounds contains the same intermolecular forces, 1 mark. Chain length increases from propane to pentane. It means I'm now saying that there is an increase in chain length as you move from this compound towards that compound. Another mark. Increase in chain length increases the strength of the intermolecular forces. Then you get another mark. The stronger the intermolecular forces, then the higher the melting point, the boiling point, and the viscosity, or the lower the water, or the lower the vapor pressure. No discussions, no long sentences in a point form. That is in terms of that. And therefore, boiling point and vapor pressure and branching. You must be able to define. This is the chain length. The factor that influences this is the chain length. But when you look at this, same homologous series, but what happens is that your compound are not the molecular formula, the relative molecular mass is the same, 72. And then when you check in there is that this molecule is more compound. It has got more branches than this molecule. This molecule does not contain any branches. It means as you move from this to that side, you are making more branches. As you move from this molecule going that side, it means your branches decreases. You are decreasing the branches. Therefore, as you decrease the branch, you are increasing the surface area. Therefore, you are increasing the strength of the intermolecular forces because you provide more area to which the intermolecular forces are going to act. And then as you provide that increase there, it means your boiling point, your melting point increases, and the viscosity will do what? The viscosity will decrease. And therefore, what is in here? Once you look at this, what you can now identify is that these compounds, they are from different homologous series. Pentane, alkane, and then what is this homologous series? That is now your aldehyde, and then this is an alcohol. Therefore, it means what is more important between this is that the type of a functional group is not the same. And as the type of the functional group changes, it means the type of the intermolecular forces also changes. And therefore, this will contain only the London forces, the weakest. This will contain, in addition to the London forces, here we have got the London forces, but in here we have got what? We have got the dipole forces. Here, in addition to London dipole forces, you have got the hydrogen bonds. And therefore, that is why we will be saying that the stronger the strong hydrogen bonds will need more energy to overcome the bond, to overcome the intermolecular forces. Let's correct that. That is one of the mistakes. We overcome the intermolecular forces, we don't overcome the bond. And therefore, that is an example of that. And therefore, let's look at some of the errors that our learners have made from the previous question papers. This is the internal moderators report from last year. I won't go to the question paper, but I hope I will just recall what the question was all about based on the question of time. In question 2.1 last year, I guess learners were asked to define a homologous series. And we have looked at that definitions of a homologous series. And what happens is that learners were penalized because they left the word organic. What are the homologous series? A group of organic compounds. Therefore, they left that organic and then they were penalized. Saturated compound, they left the word only. It is saturated because it contains only carbon-carbon single bonds. So that you can qualify that there were no other bonds except single bonds. Therefore, that word only is there. And learners cannot define what a functional group is. You can see this, and this. These are the definitions. And then it means those learners, you lose 6 marks. Very important. They cannot identify the correct pairs, 2.5.4, and the type of isomers in 2.5.5. Those who correctly identify the pairs face to give their correct names and types of the isomerism. It means in that questions what happens is that they were given pairs of organic compound of what? Of isomerism. And then they were asked to identify what type of isomerism is that one. Whether chain, whether functional, or whether positional. And therefore they have to identify the pairs. That this pair is a pair of positional isomer, this pair was a pair of a functional isomers, and therefore they were supposed to identify that. 7.2, they could not draw the structural formula of the functional group of esters. Instead, they wrote the ester linkage. It means that is what I have emphasized, that whenever we draw the structural formula of a functional group, is that this is the structural formula of the functional group of the what? Of the alkanes. No hydrogens are added there. Then what happens is that learners, when they want to draw the structural formula of the functional group, they add there the hydrogen, they add there the hydrogen atoms in there. Once you add those hydrogen atoms, it means this is no more a structural formula of the functional group, but this is now the structural formula of a compound known as the what? Known as an ethane. But this is not an ethane, it is the structural formula of the functional group of the ethane. And therefore, when naming compounds, 2.8.1, they left out the hyphens or placed it in the wrong word, in the wrong place. You will be penalized, my dear learners, if you left there the hyphens. It means if it is 2, then it must be 2 bromo. Then there is a hyphen 3 chloro. And then this is a what? This is a pentane. This is a pentane. It means a hyphen is between the number and the name. Between the number and the name, we expect the hyphen. But if I'm having a compound that is 2, 3, therefore it means 2, 3 will mean same substituents on the same carbon atoms. Then because between this is the number, therefore that will be a di-what? That will be a di-bromo. Therefore it means now between the numbers we have got what? We have got a comma. And then between the number and the name we have got what? We have got a bromo. And then this is a what? This is a pentane. Then what happens is that most of the learners will now put a 2, and then what happens is that a dibromo, I'm just trying to make an example, and then there is a what? There is a pentane there. Therefore, it means you'll forfeit a mark for that. You'll forfeit a mark for that. You'll forfeit a mark for that. It means what is essence, what I'm trying to drive home is that between the numbers, we use the commas. Between the number and the name, that is where we use the what? The hyphen. But there is no hyphen between the what? Between the names. And that is what is meant by that statement. And then definitions, I have already emphasized the concept of the definitions. Physical properties. They wrote van der Waals forces instead of being specific about the type of intermolecular forces. Given 2 molecules, you must say that one contains hydrogen, one contains London forces. So that we can be able to say what is happening in those molecules. Longer chain length with weaker intermolecular forces. Struggle to define the term melting point Explanation: incorrectly indicated the higher boiling point, the lower the melting point. Incorrectly indicated the higher the boiling point, the lower the melting point. They did not seem to understand the relationship between boiling point, melting point, and the strength of intermolecular forces. And that all of this emanate from being unable to identify the type of intermolecular forces and compare the strength of the intermolecular forces. And this was in terms of the reactions. They could not name and differentiate between different types of reactions. Struggled to name compound B, which was a butane 2-ol. They wrote but2-ol. It is a butane 2-ol. And they omitted the hyphen or placed it in the wrong position. That is what I have already emphasized. Reaction conditions. My dearest learners, you must always look for the reaction conditions for every chemical reactions that you'll come up with. The words like heat without that mild heat. There is a difference between heat and mild heat. And we now step off organic chemistry, then we look at this other one, which is what? Which is light. In terms of light, this is what you must know. Definitions: what is a wave? What is the reflection? What is refraction? What is critical angle? What is the dispersion? A wave, it is a disturbance that transfers energy through matter or space. Reflection means the change in direction of a wave upon striking an interface between two materials. Refraction is the bending of light when it passes from one medium towards another. Refraction, it must pass from one medium towards another. Reflection, it must reflect, it must bounce back, it must come back. When it strikes an interface, it means it was moving in one medium, it strikes the boundary of another medium. Instead of passing through that, then it reflects back. Then critical angle, that is an angle of incidence in the denser medium, such that the refracted ray just passes through the surface of the, and then the dispersion. We break light into components, colors. Dispersion will be dispersion of the white light. Discuss loss of reflection, loss of refraction, total internal reflections, and then conditions, and then state the use of that total internal reflections. Discuss the frequency and wavelength of various components of light. Discuss and draw transmission of light through a convex and a concave lens. When the object is placed between F and what and twice F, when the object is placed between the F and the lens, and then you must be able to draw. We are not asking for an accurate scale drawing. You are just asking for just drawing to indicate now where will be the position of the image when you place object at different position behind on the other side of the mirror. Then applications, it is a learning work. Properties, it is a learning work. This is just what we have. This is light that interacts with the object. When it interacts with transparent material, it means it will pass through. And then we'll be talking about refraction. Light interaction with object, transparent material, it moves through. And then definition is the refraction, bending of light when it passes from one medium towards another. Here is the light. We found ray of light drawn without arrows. That is one mistake that you are committing. This is a ray of light. It's coming from air into glass, two medium of different optical density. Then because now it passes through, we are talking of refraction. But now it encounters an opaque substance, a substance that does not allow light to pass through. It bounces off. Then we are talking of reflection and sometimes the absorption. And therefore, drawing of the ray diagrams is very important. This is an incident ray with an arrow. There is always a normal, there is always a normal. Our angles are measured between the ray and the normal, 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 between the ray and the normal. We found last year that learners were naming or giving the angles between the ray and the what? The ray and the and the object, your angles will always be between the ray and the normal, between your ray and the normal. Then we are talking of an incident angle, we are talking of the refracted angle. Incident, reflection, refracted angle. That is what we need. And therefore, we are not concerned with the Snell's law, but I hope that maybe your teacher will take you through that so that you can understand that it is an incident ray with an arrow. There is an angle, that is the incident angle, and then it passes through from one medium towards another medium. Therefore, what happens is that it is now refracted. But in this case, it means it is refracted towards the normal, not away from the normal. It is now refracted towards the normal, because this medium and this medium have got different optical densities, and therefore it means this is what you must know. When will it be refracted towards the normal? When will it be refracted away from the normal? It means when it is refracted towards the normal, it moves from a medium of less optical density, or of less optical density towards the medium of high optical density. It means refractive index here is lower than the refractive index. It is not the same as here when it moves from water towards air. Then it is now, here we are talking about total internal reflection. When the angle of incidence is greater than the incidence stays within the same the incident line stays within the denser medium. It means this medium is more denser than this. Light is moving from a more denser medium to a less denser medium. Then the ray is refracted away from the normal. Here it is moving from a less denser medium towards a more denser medium. The ray is refracted towards the normal. This is what you must be aware of. And then this is what we mean by the critical angle, that when we started here, this is the incident angle. And then your light, because it's now moving from more denser medium towards a less denser medium, refracted away. Then as you increase that critical angle, it means this incident angle, then your critical angle, your refracted angle also increases. And then when your ray moves in here, then we are taking off this incident angle as the what? As the critical angle, because it gives that angle of refraction 90 degrees, such that your ray just passes and in the boundary of that. You increase that. As you increase that, what happens is that the ray now is reflected back towards this, such that now your incident angle is equals in magnitude towards your what? Your reflected angle. And then that is what you must know. And then total internal reflection, what are the uses of that? Optic fiber used in endoscope, because they carry a large amount of that. And therefore this is learning work, my learners. You must just go and learn that. And then the conditions for total internal reflection to take place: light is in the denser medium and approaches a less denser medium. It means for total internal reflection to take place, therefore light must be moving from a denser medium towards the less denser medium. That is one condition. The angle of incidence is greater than the critical angle. Then for the total internal reflection to take place, the angle of incidence must be greater than the critical what? Must be greater than the critical angle. And therefore, that is what? And then this is the dispersion of light based on different frequencies of what? Based on different frequencies of light. And what you must know about light: lenses. My dearest learners, this is what I was explaining, that this is a convex lens, this is a concave lens. It is thicker in the middle, thicker at the center than at the edges. At the edges, towards the edges, it budges. This one is thicker at the edges, but thinner in the what? But thinner in that. And therefore, you must know all what happens in that. And these are the common errors and misconceptions. you can bear with me from there to here. The law of reflection, this is you must just state. They cannot tell how the light ray should be incident on the rectangular glass block for it to emerge from the opposite side of the block without being refracted. We know that if I am having this as a rectangular block and then this is air, if you incident a light not at an angle, but this is my normal, and then you incident a light parallel towards the normal, it won't undergo any reflection, but it will just pass through that without being reflected. For it to undergo, to be refracted, it means that light must be incident at an angle towards what? Towards your normal. Then it will be change what? It will change the direction when it goes on the other side. It will change the direction when it goes on the other side. And definition again, they cannot identify the type of the image formed in a flat mirror. These are the level 1 types of questions. And refraction of light, candidate could not relate wavelength frequency to the dispersion of white light. In 8.2, some wrote wavelength and frequency without any justification. Wavelength and frequency to the refraction and to the dispersion of white light. They just wrote Roy G. Beef instead of the spectrum. They could not explain why green light at a higher frequency had a higher energy than the yellow light using the frequency and wavelength. The formula E is equals to HF. E is equals to HF. This is your constant, which is your Planck's constant, which means that energy will be proportional towards the frequency, which means that you increase F, then your E is also going to increase. It means all those light that have got a higher frequency will basically have got the higher energy of the what? Higher energy of a photon. That is why the statement here that they could not explain why green light had a higher energy than a yellow light. Therefore, once I can read that statement, green, yellow, green has a higher energy. Therefore, I will just say that green light has got a higher frequency than what? Than yellow light, because of its higher energy from the formula. That is what we expect you to do. And this is an electromagnetic radiation definition, and discuss the properties of that. These are the learning work. Use the equation C is equals to F lambda to solve equations involving speed, frequency, and wavelength. Your C will always be constant. It's 3 multiplied by 10 exponent 8 because we are referring towards the light. And you know the relationship between frequency and lambda. That if frequency increases, then lambda will do what? Lambda will decrease. And also on that formula, also remember that this formula E is equals to HF can also be written in the form of E is equals to HC over F. This formula, this comes from the formula of C is equals to F what? C is equals to F lambda. Therefore, this now is meshed into this, incorporated or meshed into that formula, and therefore you can be able to calculate the energy of the what? The energy of the photon using this formula. And use the equation to do calculations of frequency, and then I've also indicated there the other formula that you can do there. And then this is just a schematic representation of the electromagnetic radiation, that we have got the electromagnetic spectrum. Range is called the electromagnetic waves, and therefore what do you have there? This is a definition: self-propagated, changing magnetic and electric field that are mutually perpendicular to each other. Changing magnetic and electric field that are mutually perpendicular to each other and perpendicular to the direction of the propagation of the wave. Then they can travel through vacuum in an empty space. Sun's energy goes through to the Earth, and then photon and give energy E is equals to HF, energy of a photon. And electromagnetic spectrum, which include all these waves: radio, microwaves, infrared, visible, ultraviolet, X-rays, as well as the gamma rays. You can see as you do this that from here to there, then the lambda becomes smaller, and therefore you can be able to play around with the formula E is equals to HF, looking at that. And then these are the electromagnetic waves. They have got the wave property. They are wave. Distance between wave crests is unit of meters. Frequency as defined there, number of waves per second, that is the with the SI units of what? Of the hertz. Remember in here, they can behave as a wave, and they can also behave as a particle. They behave as a wave, we talk of the energy of a photon. They behave as a particle, we talk of the photon. They contain a photon, then that is the energy of a photon. They behave as a wave, they can undergo all the properties of a what? Of a wave, that is your refraction, etc., etc. And then these are the misconception. In most of the misconception, I'm sure by now you are aware that definitions are our downfalls. Learners cannot define. Correct conversion of wavelength from nanometers towards meters. How to convert from nanometers towards meters? We multiply by 10 exponent negative 9. Sometimes you might not be given nanometers, you might be given another SI unit besides the nanometers. But you must be able to convert. Rounding off and the omission of the SI units at the final answer. We only round off to 2 decimal places at the final answer. Don't round off in the middle of the one, in the middle of the answer, right? And electrochemistry. This is the last part of the paper. And I will say that based on time, we have got only 30 minutes to discuss this. But I think we can take a break of about 5 minutes. Then after that 5 minutes, because I'm aware that I have pumped you with a lot of information. Then about 5 minutes, I'm checking my time. It says 15:29. Then at around 15:35, then we'll come with this electrochemistry. Then we'll be able to finish it. Then I hope that let's take a short break of 5 minutes. Thank you. Alright, welcome back, learners. The last 25 minutes will be crucial as we'll be looking at electrochemistry, which is one part that I think most of the marks can be collected if you work smart and clinical. As we look in here, oxidation and reduction, these are the terminologies that you must know. You must be able to define what is oxidation, what is reduction, in terms of the loss of electrons and the gain of electrons. And you must also be able to define that in terms of the oxidation numbers. What is an oxidizing agent? Remember, oxidation is a process, reduction is a process. Oxidation is the process of the loss of electrons, reduction is the gain. But an oxidizing agent, it is a substance that is reduced. It means an oxidizing agent does not undergo oxidation, but it undergoes reduction. Because it causes another substance to undergo reduction. It causes oxidizing agent. It causes another substance to undergo reduction. Hence, it is a substance that is what? That is reduced because it causes the other substance to undergo reduction. It gains electrons, or a substance that undergoes the reduction. Then reducing agent, same way. It cannot undergo reduction, but it must undergo oxidation. And itself is oxidized, then it loses the electrons. Electrolysis, it is a process. Decomposition of a substance when electric current is passed through it. You must be able to define a cathode as the electrode and anode as the electrode. Cathode electrode where reduction takes place. Anode the electrode where oxidation takes place. Write down the following reaction: oxidation half reduction, oxidation half reaction, reduction half reaction, and overall cell reaction by combining the two half reactions. That is why I'm saying that it is very important that you can collect the marks, because your oxidation half reaction, reduction half reactions are given in the standard table of the standard reduction potentials. There, where I said in the beginning that make it a point that if you stick to table 4A, stick to table 4A, because your teacher taught you using table 4A. If you know table 4B, don't switch between the tables. And then assign oxidation numbers, know the rules of assigning oxidation numbers into various molecules. And you must be able to differentiate between electrolytics and galvanic cell in terms of the energy transferred, energy change. That one converts electrical energy to chemical energy, that is electrolytic cell. That is why we call that the reaction there is non-spontaneous. Hence, you will need an electrical energy to run that non-spontaneous chemical reaction. Define a voltaic cell or a galvanic cell. Chemical energy is converted to electrical energy, spontaneous chemical reaction. Remember what happens here. We have got a spontaneous chemical reaction that produces electrical energy. Hence, you will need a voltmeter in that cell so that it can indicate that there is current flowing. Whereas in an electrolytic cell, you will need electrical energy, your battery or cell, to indicate so that they can, electrical energy can run that non-spontaneous chemical cell. And then define and understand the processes and of the redox, the process and redox reaction taking place in an electrolytic cell, in terms of the movement of ions in the solution, direction of the electron flow in the external circuit, writing of the equations of half reactions on both anode and cathode, overall cell reaction when you combine the oxidation half and the reduction half, and describe using half reactions and the equation for the overall cell reaction, as well as the layout of the particular cell using a schematic diagram, the following electrolytic decomposition of copper 2 chloride, components of a galvanic cell. And what do you know? The movement of ions, we have stated that. Electron flow, we have stated that. Cell notation, we will look at that. cell terminals. We'll look at that in the slides to come, and predict the half cell in which oxidation will take place when two half cells are connected. Therefore, it means you use now the table of standard reduction. Predict the half cell in which reduction will take place when connected to another half cell. The table of standard reduction is very important. That is what is important. Use a positive value of the standard EMF as an indication that the reaction is spontaneous under standard conditions. Learners, when you calculate the E naught value for a galvanic cell, you will never get a negative answer. It means if I'm given a galvanic cell and then I calculate the E naught value of that cell and then I get a negative answer, then I must just say that there must be something that I have done wrong, because that is a spontaneous chemical reaction. It will never give you a negative answer. The only one that can give you a negative answer will be for a non-spontaneous chemical reaction that is in an electrolytic cell. And then also alternate energies, biodiesel fuels. Therefore, you must discuss the use of alternative energies. Those are free marks, that is for learning. And then this is one electrolytic cell that we have, and it is a what? It is an electrolytic cell. It is an electrochemical cell. But what type of an electrochemical cell? It is an electrolytic cell. And therefore, what is important in there? It needs this source of energy, because the reaction, it is a non-spontaneous chemical reaction. In here we have got an electrolyte, the solution that can conduct electricity, because it contains both positive and negative ions. And then once you connect it towards the external source of electrical energy, that electrical energy is going to run this. And then it uses carbon electrode, and this is the inert electrode. And based on the scope of the chemical technical science, we are not concerned with the active electrode, but we are concerned with only inert electrode. It means inactive electrodes that are not going to participate in there. That is why carbon. Don't bother with the with the active electrodes, because active electrodes are not part and parcel of that. And therefore, this is an electrolytic cell. It means once it runs, copper, chlorine ions will be attracted towards the positive electrodes, which will be your anode. Anode oxidation, loss of electrons. Therefore, chlorine gas is formed, bubbles of gases will be formed. Then the electrons will move in the external circuits towards your cathode. What happens is that your copper 2+ ions, which are positive ions in the electrolyte, attracted towards the negative electrodes. They undergo the reduction. It means they gain the electrons, and then they form a copper. It means I'm expecting what? Due to the formation of the chlorine gas, the bubbles of a gas will be formed here. Due to the formation of the copper, I'm expecting a deposit of the of a layer of of copper around here. Increase in mass of that electrode. And this is now a galvanic cell. Remember what is the difference in this? This one was a non-spontaneous. This one is a spontaneous chemical reactions. Anode is separated from the cathode. Your anode is negatively charged. Your cathode is negatively charged. Oxidation in here, and then reduction in there. There is a salt bridge. Remember the functions of the salt bridge: to neutralize the to neutralize the electrodes, the electrolyte in the two half reactions. Like you can see that in here, iodine ions are losing the electrons to form an I2 plus 2 electrons. That is your oxidation half reaction. Iodine is formed here. In here, what happens is that this is graphite, that is graphite. Manganese oxide now gains the electrons, and then what is formed is Mn2 plus that. And then this is the cell reaction when you combine the two half reactions, and then at the end of the day you have got this. this is the net cell reaction. It means this is MnO4 minus, then it reacts with there is an CH plus, and then there is an iodine, then you react, you get what? The Mn2 plus your iodine plus water. Very important that you must now regard that what is basically reacting here. That is where the concept of the oxidation numbers comes now into effect. That your iodine ion is now converted into iodine. This is one reactant in there. And then when you allocate the oxidation number there, you'll see that your manganese is now converted into your manganese ion. And then all these other reactants will now be your what? Will now be your spectator ions, because their oxidation state does not change. Therefore, it means what is basically changing? What the substance that their oxidation state changes are the substances that undergoes a change, or that undergoes reduction. You can see in here, you started with an iodine ion, and then you ended up with an iodine, and therefore oxidation number changes from negative towards zero oxidation state. You look at the manganese, what happens is that you have a manganese ion in here, and then its oxidation state changes towards what? That was a manganese. Its oxidation state changes towards a manganese what? Towards a manganese with an oxidation number of what? Of 2 plus. And therefore it means that is what is happening here. Then this is the cell notation for that. It means this is an electrode, this is a carbon electrode. And then an iodine ion is now oxidized towards iodine. And therefore, carbon electrode, it means that is where the reaction is going to take place. And therefore, this is represent your salt bridge. And therefore, you have got now the reduction half reaction that is taking place on that now. At the end of the day, it means what happens is that we have got what? We have got your manganese 2 plus ion. And this is the electrochemistry. And we are not concerned with the active electrode. That is why I'm not going to bother about that. And then these are the misconceptions. They cannot identify the type of reactions, could not define in electrolyte, could not define oxidizing agent. It means all those definitions, you'll agree with me that since we started this the broadcast, all that is there is that definitions, and then writing of half cell reaction, overall cell reactions, definitions of a galvanic cell towards an electrolytic cell. They cannot state the functions of the what? Of the salt bridge. These are the recall types of questions. Explain the change in mass, etc. They swap the anode and the cathode when substituting in the formula during calculations of the EMF. This is the formula. E naught of the cell is equals to E naught on the cathode minus E naught on the anode. And that is that, you my dearest learners, in terms of that. But there is a slide, very important slide, that I want us to look at the end of this. And therefore, what is that slide? This is just the strategies that how we can improve the things, the performance. Low order questions. Because the paper, 40% of the paper consists of the low order questions, that is your level 1 questions, your definitions, etc. Focus on knowing those definitions so that you can collect as many marks as possible. Write those definitions down as much as possible. Definitions and principles must be stated from the examination. You have got the definitions from the examination guideline. Go and memorize those definitions so that when we say define oxidizing agent, you can define oxidizing agent. Go and define what we call define homologous series. As they are from the examination guideline, go and memorize those definitions. Use a formula sheet at all times when referring towards a formula for a calculations. There are many calculations in paper 2. I guess one calculation that I can remember, it is the one that we have referred to, calculations of the E naught of the cell. Another calculations that I can remember is on light, calculations on light, the speed of light, C is equals to F lambda, E is equals to HF naught. And be clear about the constant values on the data sheet. What is a Planck constant? Then you can get that. F sort in calculations. We give a mark for the formula provided that there is an attempt to substitute in that. We give a mark for the answer. We give a mark for the SI unit. And if it is a vector, then we'll get a mark for that. And then this important slide that I was referring to, it is this slide. That is the marking principle for paper 2. And please listen to me and then listen to me attentively, because this is where most of the learners have lost marks. If one answer or calculation is required, but 2 are given by the candidate, only the first one will be marked, irrespective of whether which one is correct. We have got the scenarios where learners will give 2 answers saying this or. We have got the situation whereby a learner is now answering question 2.2.1. Let's say he's now calculating this E is equals to HF, then Planck's constant, and then calculate the answer and then give the answer in joules, 2,10 joules. And then the learner will now be saying or, and then give us the other calculations, and then he calculate, and then the answer now becomes 4,10 joules of energy. Then when we mark, we only consider this answer. Then this is considered as the second attempt of that learner. Therefore, it means if this is correct, we are only going to mark this, and then you will forfeit this. Try as much as possible that you give us only one answer, not or what. Only one answer, and then that answer must be the correct one, because we don't mark the second attempt. We regard this as the second attempt. And when a chemical formula is asked and the name is given as an answer, the candidate forfeit the marks. You'll find that in most of our questions, you'll find that the examiner will now say that maybe for 2.2, then the examiner will say write down the formula, and you'll find that these are always emphasized. This will be written in capital letter or bolded in the question paper. Then when it is written in capital letter or bolded, then it must say that the examiner is looking for the formula or not the name. Then you must give us the formula. Then if you give us the name, because the examiner has asked for a formula, then you forfeit those marks. Then the same rules applies. When we ask the question, ask for a name, and then you give for the formula, then you forfeit that. Then always look for the letters in the questions, those words that are written in capital letters or that are bolded. They guide you. They say to you, we are looking for the formula or we are looking for the name. That is one thing that you must always take into consideration. When candidates are required to give an explanation involving the relative strength of oxidizing and reducing agent, the following will not be accepted. You cannot say to us that the position of the substance in the table for only that Cu is above Mg. That is an incorrect. You must explain to us what is the relative strength. Then you must be able to say that Mg is a stronger reducing agent than copper, and therefore Mg will be able to reduce copper 2 plus iron towards copper. Don't say that Cu is above Mg. You must tell us about the strength of the reducing agent. 1 mark is always forfeited when the charge of an ion is omitted per equation. You want to write the equation that this is 2Cl minus, they are oxidized towards Cl2 plus 2e electrons. Then you omit the charge on the what? You omit the charge on this. Those charges are very important there. Then what will happen is that you will forfeit what? You will forfeit 1 mark. It means for this, we always get what? We always give 2 marks. But if that is not there, then we take 1 mark and then you will get 1 out of what? 1 out of 2. And then it is very irresponsible because these reactions are always given from where? From the table of standard reduction. Take them as they are, put in there, the charges there. And the error carrying principle does not apply to chemical equations or half reactions. For example, if a learner writes wrong oxidation or reduction half reactions in the sub-questions and carry the answer to another sub-questions, balancing of equations or calculation, then the learner will not be credited. What is meant in terms of that is that if you are the question was write down the half reactions at the half reactions at the cathode. We know that at the cathode what happens is that the reaction that must take place there, it is the reduction half reaction. But instead of writing the reduction half reaction, then you give us the oxidation half reaction. Then this reaction will say that the chloride ions loses the electrons and then they are oxidized. That is the loss of the electrons. But the question was looking for the reaction at the cathode. When now you gave us the oxidation half reaction, it means you forfeit these marks. And then you go further, they'll say this was question 2.1. In question 2.2, then you are now required now to calculate the E naught of the what? The E naught of the cell. Where you are now going to use the equation E naught of the cell is now equals to E naught on the cathode minus E naught on the what? On the anode. But because now you have given us the incorrect answer in question 2.1, then you carry that incorrect answer towards this question. You are not going to be credited. That is what is meant by the word. That is what is meant by this, that the error carrying principle does not apply. It means you will forfeit the marks in what? In question 2.1, and you will also forfeit the marks in question 2.2. It means it causes you more and more of the what? Of the marks if the other questions are not answered correctly. Therefore, you must be on the lookout for such types of what? Of errors, right? In the structural formula of an organic molecule, all hydrogen atoms must be shown. I have alluded towards that. Marks will be deducted if the hydrogen atoms are omitted, or if a carbon atom has formed more than 4 bonds or less than 4 bonds. When structural formula is required, marks will be deducted if the candidate writes the condensed structural formula. I don't know where do you get this condensed structural formula, because in technical science there are no condensed structural formula. When the IUPAC name is asked and the candidate omits the hyphens, I've already said that instead of pent 1 in, the candidate writes 1 pent in. There must be a hyphen there. 1 mark is forfeited. Chemical reaction is asked. Marks are awarded for the correct reactants, correct product, and correct balancing. If only reactants are written followed by an arrow, only 1 mark is given there. It means if you have to write down combustion of that, therefore C4H10 C4H10, that is the reaction that I wanted to refer to, that C4H10 plus O2. This is the reactant. You are not going to get a mark for that reactant if that arrow is not there. Once we see that arrow, then we can give a mark. And then you write CO2 plus H2O, then we can give a what? We can give a mark. Therefore, without this arrow, this mark is not awarded there. And that is what is meant there. By an arrow, only product can proceed by an arrow. Then marks will be awarded for the reactants or product. If only reactants are only product, or only a product is written without an arrow, no marks will be awarded for either the reactants or if this arrow is not there, this mark and this mark is forfeited, because we don't know which one are the reactants, which one are the product. That is that. And my dearest learners, what are the resources that you can use? Old question papers from the DBE website, textbooks for learners to study. Every learner was provided with a package where we have packaged the questions with the memorandums. Therefore, just look at those questions and the memorandum at the end. Just see how the questions are being marked, and then use those questions in order to prepare for the final examination. And I just hope, despite all the difficulties that we went through for these years, there is still a hope at the end of the day. Just prepare for the tomorrow's paper, that is paper 1, thoroughly, and prepare thoroughly for paper 2 over the weekend, and just use every opportunity that you have to go through the material and make sure that you come to the examination as prepared as possible. This is one advice that I give to my learners, that our exam starts at 9 o'clock. You must be at your schoolyard at around 20 past 8. 8:30, you move towards your exam center. Then by 8:45, you are seated, you are getting your examination scripts, etc. Then just go through the exam paper before you answer that question paper. Just go through all the questions from question 1 to question 10. Identify exactly the questions where you can collect marks. Examination is all about collections of marks. Start with those questions that you are sure that you can collect marks. We sit with a situation where we found someone struggling with a multiple choice question 1.6 of 2 marks, spending about 20 marks, cracking his head or her head about these 2 marks. Whereas there is question 10 there on electromagnetism where you can collect marks. Start with questions that you basically know that you can answer, so that by the time you start thinking about these difficult questions that you don't know, then you have already collected marks. But a minute you arrive late in the examination, all candidates have seated, and then there you come, and then you are already 5-10 minutes late, you open a question paper, then you are already panicking. Therefore, it means some of the questions that you even know, then you might not even be able to answer that. Make a thorough preparation, have a thorough rest, and then be aware of this, control all these factors that can have got a negative effect on your preparation. Remember, this is your future. It all lies in your hands. And then by those words, I will just like to say that everything of the best for tomorrow paper and the Monday paper. We wish you all of the best, and all of the best also for the future. Thank you.